Hey everybody, in this video we're going to talk about solving a quadratic inequality written in factor form. But before we do that, I want to talk a little bit about what a quadratic inequality even means. So let's take a look at this equation when we're told to solve by graphing. So what we're going to do is we're going to say, hey, we've got this quadratic function here. We're going to find where the outputs are 0 with the graph. So where my y values are 0, that's going to be my graph. So that's going to be my solution. So f of x equals x squared minus 12x plus 35. Now why did I write that over there? Because I'm going to complete the square on this so I can get this into vertex form. And I'm going to graph the quadratic equation. What am I going to add here? Well, I'm going to add 12 over 2 times 1 squared. Where did that come from? Negative b over 2a. Okay, so that ends up being 6 squared, which is 36. So remember, if I add 36, I also have to subtract 36, so I add a total of 0. The x squared minus 12x plus 36 factors into x minus 6 squared, and then I have minus 1 left. So my vertex from this equation is at 6, negative 1. So I'm going to have a vertex here. Now, to plot this, okay, let's plug in 6. Oh, that was my vertex, so I'm going to get negative 1. When I plug in 7, I'll get 0. When I plug in 5, I'll get 0. When I plug in 8, I'll get 3. And when I plug in 4, I'll get 3. So my parabola is going to look like this. So what are the x values when my outputs are 0? My outputs are 0 here and here. So there's my solutions. So my solutions are at x equals 5 and 7. So that was when our function was equal to 0, right? Our outputs were equal to 0. But what about when we have an inequality? So let's say instead that we want to know when our function or the outputs of our function are more than 0. What is that going to look like? Well, for what x values are my outputs above the x-axis? That's going to be for all the x values from 5 to negative infinity. But we're not going to include 5 because at 5 we're at 0. We want it to be greater than 0. And then from 7 to infinity. So I'm going to have a range of values. Where is a graph greater than 0 or above the x-axis? This is what this is saying. Well, from negative infinity to 5, and then from 7 to infinity. Right? So that's what we're doing when we're solving an inequality. So for this inequality, my polynomial or my quadratic is already factored. Okay, that's going to be one of the first steps, is to get it factored. If it was not in factored form, we would have x squared minus 3x plus 4x minus 12 is greater than or equal to 0. Okay, but then we could factor that down. We could combine like terms to get the original, but then we could factor this down. Now, remember, with that parabola, wherever my function is 0 is where I'm going to have a change between either above the x-axis or below the x-axis. In this case, we want it greater than or equal to 0. Okay. But where are those going to take place? Well, that's going to take place wherever my function, or that change is going to take place wherever my function is equal to 0. And that's going to happen at x equals 3 and x equals -4. So think of those almost as boundaries or critical points where my graph is changing from above the x-axis to below the x-axis. So we're going to have one at -4 and +3. Something's happening there. And we are, in this case, going to fill in the circle because we do want to know where the function equals 0 as well. Okay, but what about where it's greater than 0? So this is where we check points. So if I were to check -7, I could plug that into my function, -7 minus 3 times -7 plus 4. Now this factor, -7 minus 3, is -10. And then -7 plus 4 is -3. So I'm going to end up getting a +30. So within, no matter what I check, between -infinity to -4, it's going to be positive. Which is what I wanted, right? My entire function is going to be positive. Let's check 0. So this is going to be 0 minus 3 times 0 plus 4. Now I'm actually not worried about what these values actually are. I'm worried about the signs. 0 minus 3 is negative, 0 plus 4 is positive, and then we have a negative times a positive, which is going to give us a negative out. Let's plug in 7, because we could plug in 4, 5, 6, 7, 8, 9, 10. Doesn't matter as long as it's within this interval, because the only place it's going to change between above the x-axis and below the x-axis again are these 0 values which we found. So we're going to get 7 minus 3 times 7 plus 4. 7 minus 3 is positive, 7 plus 4 is positive. So we end up with a positive here. So I wanted my intervals wherever it was going to be greater than or equal to 0. That happens from -infinity all the way to -4, and then from 3, including 3, all the way to positive infinity. And we draw little lines because those are x values that are going to make the statement above true. So between -infinity and -4, and then from 3 to infinity, our outputs are greater than or equal to 0, or our function is above the x-axis.